All right. Hello and welcome, everyone. My name is Ryan Moffitt, Customer Service Technical Support Specialist here at Radiant. And today I'll be covering CT testing on both the RW and Bantam Plus test systems. So for this presentation, I'll be doing some demonstration over my PC as well as right behind me using my meter test system and CT wiring over here. So we recommend using a side-by-side view in WebEx. Side-by-side can be selected at the top right corner of WebEx, which will allow you to view myself in the webcam, as well as what I'm doing behind me, also what I'm sharing on my screen at the same time. When in side-by-side view, you can hover over the borders of each screen and click and drag left and right to make each screen larger or smaller depending on what we're presenting on. With that kind of overview of what I'll be covering today, first we're going to talk about the RW and go over hardware connections needed to perform a CT test, software setup that goes into setting up your CT test, running said CT test, DMAG, its functions, and when not to use it, as well as saving the results you get off of the RW. After discussing the RW, we'll be transitioning over to the Bantam Plus and talking about its CT testing accessory, the RB-TSVR1, a burden ratio tester add-on for your Bantam Plus. So with that, first we're going to talk about hardware connections behind me. For this setup, I have a wired meter can here for a 9S meter form. I have a load box that is generating voltage and current into the primary of my 3 CTs, and then secondary is being wired down here at the bottom to provide that secondary current to the meter. For this test, everything will be de-energized while I'm connecting up. So from a safety perspective, I'm not wearing anything here in the office because this is a controlled environment, but if you're out doing this out in the field on a live site, we recommend abide by your utility or otherwise PPE requirements. So wear the appropriate gloves and protective equipment for you when you go out and do this for real at a live site or in the field. With that, we're going to talk about the hardware connections needed on the RW side to hook up to perform a CT test. This hookup is valid for several things on the RW. Even though we're just focusing on CT testing today, this hookup is also valid for customer load meter test results as well as power quality. So you can use this setup to run power quality, customer load meter tests, as well as what we're doing today, CT testing. So for the RW, you'll need 2 sets of cables that plug into the RW's front panel. First is alligator clips for voltage, as well as your duckbill cables for current. So the first thing we want to do hardware-wise is to get our voltage in line with the RW, so the RW sees exactly what the meter is going to be seeing in this case. So first, we're going to take these alligator clips and hook up to the top of our test switch. A side note about this test switch, my test switch here is voltage A, B, C, and neutral, and then current A, polarity and return, current B, polarity return, current C, polarity return. Yours might differ. Yours might have voltage and then current, then another voltage, another current, another voltage, another current, neutral. It varies out there. This is my setup. So when you go out and do this yourself, don't mimic exactly what I'm doing. Instead, base it off your knowledge of your own test switch and connect up accordingly. With this, what we're going to want to do, flip up our A phase voltage to the top of the test switch, get in line with voltage, B phase, C phase, and our neutral. So with this setup and the alligator clips clipped up to the top of the test switch like this, we now will be seeing all three phases of voltage on the RW. For current, get untangled. We have our duct bills. These are a little bit trickier than the alligator clips. The alligator clips you can just clip right up. But for these, there's a little procedure to it. What I recommend doing is to insert the duct bill. First, you'll need to short out the CT secondary to deaden the meter on that specific phase. Open up the duct bill insert, open up the switch. With the red side up, you're going to want to push your duct bill inside of the test switch. I wouldn't push too far, but if you decide to push in, you can pull out just a little bit. If for some reason you push in too far and too hard, what might happen is the tip of the duct bill will short out against the back of your test switch, thus causing, one, to short your duct bill here, but two, an incorrect secondary current reading. So I recommend if you shove the duct bill in, pull it out just a little bit to give the room between the duct bill and the test switch so you don't short out the back end. Once you've got the duct bill inserted, unshort the secondary of the CT, and then now with this in line, we've got current going through the meter as well as the RW. For the other two phases, what you'll need to do, same thing. Short out the CT secondary so the meter's dead on that phase. Open up your switch, red side up, duct bill in. Pull out just a tad if you push it in a little bit too far. Unshort the CT. And repeat for the next phase.
Hey, Ryan. Can you hear me?
I can.
Great. I just saw a note that there was some people that may not be able to see your screen, and you might reach out to everyone and ask that question. So
again, for this WebEx part, like I said, we'll be doing a little bit of this on this side of it, as well as stuff on my screen. I've got a blank right now because the focus is going to be up here. Again, there's the side-by-side view that you can choose in WebEx at the top right of your screen. If you do that, you should be able to see the physical side of it. With this, though, this is the hardware setup for it. So with this setup I've got here, we got voltage hooked up to the top, and our duct bills are inserted safely into each leg of current. Now, though, I know some people might not be able to see this that great. If you go to the side-by-side view, that should work a little bit better. But now we're going to transition over to software and talk about the software side of the RW and setting up your CT test after you have your secondary part of the hardware going. So as you can see now on my screen, when you first boot up your RW, this is the screen you'll be greeted with. This is the main menu of the RW. And one of the options that you get is CT testing in the middle column, top row. If I click on CT testing and go into it, you get two options for CT testing. One is a generic CT test, the first option, which we'll be discussing today. The second one is dead site testing, which is using our 200 amp CT current boost module to allow customers and users to generate up to 200 amps from the RW and boost either a dead or a low current site to get a valid test out of the CT. That's going to be covered either in a future webinar, or we also have an app note that goes over the use of the CT current boost. So while that is an option, we won't be talking about it today, and instead we'll be discussing the typical CT test on the first button. When you open up CT testing, this is the window that you'll be greeted with. Kind of give you bits and pieces of everything. At the top here, we have the exit button, which exits back out to the menu I was just in. Cancel. Cancels goes back to, or cancel stops the test that's currently running. Start starts the test that you set up here in this window. Graph shows a parallelogram of the test that you ran. So right now I haven't ran any tests yet on the CT, so there's nothing to show. but it'll show the parallelogram graph and a curve for if you're adding excess burden and show where the secondary currents lie based on that. Demag, what that does is send signals out to your CTs to run a demagnetization on. The RW quickly ramps up and ramps down burden to attempt to demagnetize your CT. When would you run demag? You would typically run that usually if your ratios are running a bit high or if you think something has happened to the CT's core to have it become magnetized. Typically, you'd be reading a little higher. So these 105 CTs were magnetized. I might be reading 110, 115, something a little higher than what I would normally expect from that. So you can try to run the demag, and the RW will attempt to demagnetize that CT. We recommend doing that if you are getting some high results, but as a point to that, if you run the demag, it will change your ratio of the CT. So as a little disclaimer, if you do run the demag on it, expect a change in your ratio when you run that. Saves the results that you've ran on the RW for viewing later. And then options. Gives you a couple different options for CT tests. If I click into options, you get three options. One is a clamp-on multiplier. So if your clamp or rope probe, sensor link probe, whatever you're using to get primary data, has some form of multiplier to it. In terms of millivolts per amp, you can put in that clamp-on multiplier here. Required minimum secondary current. What this does is the RW will not start a test until it sees X amount of current on the secondary. Start delay in milliseconds is when it detects the right amount of primary current, as you'll see when I run this test, it will delay X amount of time before it starts taking readings from both primary and secondary and starting your test. So it gives you a little bit of wiggle room before starting the test and measuring primary and secondary and doing the burden ratio. Right below that is your tabs for setup and then each phase. For the setup tab, this is where we're going to set up exactly what we want to run on the RW. We can do burden test, a ratio test, or both. Burden test is adding up to 4 ohms of burden onto the CT under test and seeing how the CT performs with excess burden in the circuit. Ratio test gives you a reading from primary current, gives you a reading from secondary current, and then provides you the ratio determined by the primary and secondary current reading and gives you a ratio for CT. You can choose the max amount of burden, and you can also tell the RW what types of CTs that you're testing. So with these, like I said earlier, these are 100 to 5 CTs. So I've got 100 to 5 in as the nameplate ratio of these CTs. And then if I go ahead and check burden here, I can choose anywhere between 0.1 ohms to 4 ohms. For the test I'm going to do today, I'm going to add 0.9 ohms of burden. Usually the maximum burden that you want to put in is designated on the faceplate of the CT. Usually has some form of burden rating saying I can handle X amount of burden at X temperature. So you can look for that if you can get to the CT's nameplate. Otherwise, you can make an educated guess on max burden or skip the burden test entirely, whatever you want when you're running the CT test. To the right of that is selecting what phases you want to test for this run. You can test single phase and just do A, then do B, then do C. You want to do 2 phases, you can do 2 phases. Or, like what I'm going to demonstrate here, you can do all 3 phases at once and run one test for all 3 phases of your CT. So if I check all of these, we're going to run all 3 CTs during one test. Moving over from the Setup tab to each phase A, B, and C, this is where you can track information on the CT that you're testing. You have phase A, phase B, and phase C, and each one needs a serial number, model number, and accuracy class. Serial number can usually be read off the faceplate of the CT. Model number, it's associated with it if you have an ABB, RIB, CT, something like that, that has a model number tied to it. You want to track that, you can put that in the model number field. And then accuracy class of the CT, which also drives the graph that I showed previously. So if I change the accuracy class here, 0.3, my graph is now a 0.3 accuracy class graph that I can show off later. To save data, the RW does need something in the serial number, model number, and accuracy class field. As well, which is covered in a different webinar, you can also use site functionality on the RW to track DCT test results to a specific site that you've set up in the RW. Sites being a way to combine meter test results, CT test results, power quality, all into one uniform location. So once you've added in your serial numbers, model numbers, accuracy classes for all three phases, and you've got your test set up like I have in this case, I want to do my burden test at 0.9 ohms and my ratio test of 100 to 5 CT on all three phases. Good to go. So now we want to get the primary measurement going. For that, I have this SR704 clamp of ours. This is a clamp style probe that just clamps onto the primary. A lot more common ones as well are rope probes, sensor link probes, things like that to also get in the primary. Any one of those will work, but because of my size of my setup here, I've got a clamp to do that. These clamps for the RW plug into the A phase input only. So while you're running the CT test, the only thing you need to move is this probe. You do not need to move anything on the RW. You can leave the RW sit as is, voltage and current in line, primary probe moving only during the test. You do not need to touch anything on the RW during the test. So if I wanted to start my RW's CT test, if I go ahead and hit start over here, I'm going to go ahead and energize my setup here. That's why it's yelling at me. Because as you saw earlier in the options menu, I said, do not start a test unless it's 1/8 of an amp on the secondary. Well, if you look down at the bottom of my screen, all my amps are 0. Now, that I've got everything in line, I'm safe to energize my setup. I'll go ahead, we're going to put 20 amps into the primary. So I should see 1 amp on my secondary. And now if you look at the bottom of my software screen here, on IA, IB, and IC, we have 1 amp across the board. So the RW is correctly reading my A phase voltage for a reference voltage, as well as A, B, and C phase secondary current. So now at this point, with it reading above the 1/8 minimum secondary current, I can start my test. When you start your test, it's going to call for the CT, make sure it sees a CT probe. And now what it's going to do is it's going to wait for primary current to be read by the RW. Now wait for A phase primary current. What it's waiting for is 80% of the read secondary. So in this case, 16 amps. So with that knowledge, I can then go ahead and put this over my CT A phase primary. That message will go away and it'll start your test. You'll hear a loud beep in a second. That beep is to let you know that the CT test has been complete, and then you can move the primary probe over to your next phase. So with this, it's waiting for A phase primary current to go to 0. In other words, it's waiting for me to remove this from the primary. I've now removed that from the CT. And here in a second, it's going to pop up waiting for B phase primary current. So now it's waiting for the same thing, except on B phase. So now we're going to move my probe over to B phase primary, and repeat the test. Now for B phase. Same thing. Now it's waiting for my B phase current to go 0. It's waiting for me to pull this off. And now it's waiting for C phase. Something I want to show off real quick is the RW will tell you if you have this probe on backwards, or if it believes you have the probe on backwards. So this time, instead of hooking it up correctly, I'm going to flip this probe 180 degrees out. So now I've put it on backwards. And you'll see the RW is going to yell at me in a second. So if you were able to hear that, the RW beeps irregularly, saying that there was an issue. And the issue it just said was the polarity of your current probe might be a bit off. You might need to not do what I did and swap it the right direction. With that, it'll tell you if it thinks the probe's off, and it does that by measuring phase error in minutes. Minutes being 60 minutes for every 1 degree. So with that, it's reading negative 10,000 minutes with this, thinking that I've got my probe on backwards. So it warns me saying, hey, you might want to retry that test. So with that being shown off, though, I ran A and B. A and B looks good, but oops, I fat-fingered C, so I want to go back and rerun C. What I can do then is uncheck A and B up here at the Settings tab. And now this time around, we're just going to run C. I take my probe, I purposely threw 180 degrees out, put it in the right direction. You can have this set up either before the test or set it up during the test. It doesn't matter. So if I go ahead and put this back on C like that, it's ready to go. And if I hit start, it'll start the C phase test. So it's looking for the clamp again, found the clamp, and now it's going to run the C for C phase. So you can see the results came back a lot better than if I flipped the probe. Now they're all kind of unified, and if we look at the results here, the results after the test are shown at the bottom of the screen. You can see A phase, you can see the burden values that it was tested at. Then right over that, the secondary current that was read during that burden test step. The percent difference between no burden added as well as adding in burden. So you can see the percent difference between no burden and that burden step. The calculated ratio of that CT during that burden step. The percent error between primary and secondary. And then the phase error between the current phase angle being read by the secondary, the current phase angle being read by the probe and the primary in minutes. And then repeat for A, B, and C. Earlier on, I threw a DMAG on the A phase CT. If you decide to run the DMAG, as I said earlier, it will tell you if you have run a DMAG on that test. I'll say DMAG complete on my A phase, as you can see down there. And then B and C, I did not run on those two CTs. If you like what you're seeing and you want to save this, right up at the top, there's a save button. If you hit save, it'll save these results into the RW, and then you can retrieve those at any time later on in administration under CT test. With that being said, I want to transition over to the Bantam Plus side of things and show you guys the differences between what we just saw in the RW and the Bantam Plus. So right now, I've just killed voltage and current over to my test setup. So again, I'm safe in this case. And again, if you're out in the field, PPE definitely required for what I'm about to do. So once you're done with the RW, you can then, again, short out the CT secondary. So this is dead on this side. Pull out your duckbill, and then close both switches for that phase. And repeat for the other two. Open up the secondary, so this is dead. Pull out your duckbill. Close both switches. Vice versa. And then for the voltage, go ahead and unclip these up for voltage. And everything closed back up. Meter's happy. You're happy, hopefully, with your test. You can move on. Now going into the differences between the Bantam Plus and the RW. The RW has CT testing built into it. Bantam Plus requires an accessory to do so. That accessory is called the RB-TSBR1. It's the Bantam burden ratio CT test. And it looks something like this, with a bunch of cables in it. So this is our TSBR1, Bantam Plus CT burden ratio test. What this does is it plugs right into the socket of your Bantam. This cable right here in the front plugs into the aux input on your Bantam to receive power to this little device. And then the other end of it is your hookups to the test switch. On one end, you've got it plugged into the aux input to provide power and communication to the burden ratio test. And then on the other hand, on the other side, really, you have your CT input, which is going to be where you plug in your primary probe to the burden ratio tester. And then as well, we have voltage cabling and a duckbill, one singular duckbill. So let me bring up the voltage cabling here. It's several feet long, so I've got it all across the floor. But it's got voltage cabling running from the output of here to an A-phase and neutral alligator clip. And then your duckbill end is one singular cable, one duckbill, going into the burden ratio test. So this test, similar to the RW, everything I just showed is valid for this. But we need to do each phase individually rather than combined. That's what the RW can do. So if you saw, I could do all three in one. The Bantam is going to take 3 separate tests for each phase. So hardware connections that differ from the RW to the Bantam is going to be similar yet different, just with less connections to start with. So because we have our A-phase and neutral alligator clips, same thing, we're going to clip up to the test switch on our A-phase and neutral to get the Bantam in line with voltage at the site. And then our one duckbill, we're going to put on the phase we want to measure. So in this case, same idea. I'm going to go ahead and short out the CT secondary, deaden everything on this side, open up our test switch, red side up. I'm going to plug in the duckbill. If you push too hard, you can pull back just a little bit to not short out the back end. Close that up, and now we're in line on A-phase. So there's no difference on the software end and how to run the test on the Bantam. The only difference being you can only do one phase at a time. If you try to select A, B, and C, like what I did with the RW, the check mark will move whichever one you click. It will only allow you to choose one. It's because with the TSBR1, we have the one duckbill and the one voltage connection. Voltage connection doesn't need to move, but the duckbill will per phase. So now, if I wanted to test with this, what we can do is, as I was saying earlier, I've got my end of my 704 clamp probe that I was using. I can plug that into the TSBR1, and that fits in just like that, snaps in. That would sit on my Bantam. I would run through my A-phase test, complete that test, and get results for A-phase. Then, when I was ready to go to B, what I would do is go to my switch, open up the secondary, or not open it up, but short out the CT secondary. So this is all dead up here. Pull out my duckbill, close up my switch again. Now I want to move over to B phase, so we insert it into B phase. Throw it out so it's dead. Open up my duckbill insert here, throw that in there, unshort that to get current flow moving. And then we would test B phase and then do it again for C phase. So single phase CT testing, that can be used for a 3-phase application. So the Bantam Plus is slightly different than the RW in terms of you have to put your hands in here just a little bit more to get each phase tested, but will allow you to do 3-phase CT testing on your Bantam. And then same thing with the primary as well. We would hook up to each one that we're doing. So if I was testing A phase, I can hook up to A phase, run the test, hook up to B, run that test, C, run that test. Just let them, we move the duckbill and the primary probe right alongside each one. And then once I was done, I can then pull all those off as well. Sort that out, pull out my duckbill, that's moving the whole thing. Close up my switch. Remove all of my stuff here, unclip from the test switch. Make sure everything's closed. I'm good to go. So that kind of covers over everything CT-wise, testing-wise for the RW and the Bantam Plus. So I'm going to shift over here real quick. I'd like to open up the chat feature in WebEx for any kind of questions. If you have a question that you would like me to answer or like us as a group to answer, if you want to type your questions in chat, or if you want to discuss the question with me, say I have a question or something in chat, we can unmute you and we can talk about your question. Otherwise, the chat feature is there and I will read off questions and answer them accordingly. Is the power supply for the RW same as the Bantam? Can you use service voltage? Absolutely. The Bantam and RW typically come with a field power cable. It'll hook up anywhere between 90 to 300 volts. So if you're at a 120, 240 volt service, you can use service voltage there. If you're at a 480 volt site, you'll probably need to do face-to-face to get 277 to power up the unit. I've got a couple. Let me scroll up here real quick and get to all your questions. Polarity check confirming CT current flow. Typically for a polarity check or something like that, I would recommend using the power quality feature of the RW. That allows you to look at vector diagrams and setups, either using a primary probe or a secondary probe to manually look and match up voltages and currents that you're reading and seeing from the RW. The Bantam side, that's really going to be manually on your end. There's no power quality feature inside of the Bantam. But on the RW side, you get the ability to look at vector diagrams, harmonic contents, and a real detailed screen of what's there at the site. So you can use the power quality function of it to determine polarity and measurements at the site. Next question, why does demagnetization affect your CT ratio? That kind of goes into the physics behind the CT. Not going too much in depth into it, but magnetization of the core of the CT can cause some inaccurate results. Magnetization occurring, whether the CT's been open for a while, lightning struck the site and caused a surge, something like that. Demagnetization, what it does on our RW and most other units is quickly ramps up burden in the circuit and quickly ramps back down burden in that circuit. What that's supposed to do is to demagnetize the CT core based on prior events such as the lightning strike or something like that, which would then cause an inaccurate ratio on that CT. So if you're seeing something high, usually it's high. Almost all the time, if something's magnetized, it's going to come out higher than normal. You can use the DMAG feature and do that exact trick to potentially remedy what you might believe to be a magnetized CT. That ratio is reading higher. Scroll down here for more questions. Guessing for an underground installation, there is a flex type current sensor that would be used. Absolutely. For a lot of underground stuff, we have multiple probes that we can offer. The one I'm using is a clamp probe because it's easier to use in the office, but typically we have flex probes, the larger, some people call them rope probes. Sensor links on a hot stick are very good for reaching out of the way primary installations, whether it's overhead, high voltage, substation testing, or something underground where you need to get in there and reach down somewhere. So yes, if there's a specific application or if you're looking for something specific, you can email us and we can take a look at what you need and hopefully find the probe that works best for you. Next question. Can you test primary voltage at 2400, 4160, or 14,400 to 24,940? With the right probe, yes. Usually that goes right alongside the sensor link probes I keep talking about, the high voltage current probe. So at these substation applications, yes, these sensor link probes can be hooked up to a hot stick, ramped up, and used to measure high voltage substation applications and measure those amperages accordingly. So yes, you can test those sites with it. Scroll down a little further. Will it be able to test if there's no load or current? Two parts to that. It will be able to do a burden test. Because you can, as long as you have, well, I take that back. If there's no load, you cannot do a test on it. If you can't get to the primary, but you can get access to the secondary, you can do a burden test. If there's absolutely no load or current there, that's when I would recommend our CT current boost module that goes with the RW only. That CT current boost module will push 200 amps through a primary of a CT and allow you to test under no load conditions or bench test CT. So that's when I would talk about the CT current boost module. I can go into a little bit more detail about that later on. Or if you have any specific questions on the no load stuff, like I said, please email us. We can give you a bit more info on the current boost. So stated that a magnetized CT caused high ratio test results. Is the burden test results affected also? Not to my knowledge, but I cannot verify that one way or the other. To be honest, I do not know the answer to that question. Can you scroll down here again? Will there ever be an opportunity to have admittance testing on the Bantam? We've had feedback on the RW and Bantam Plus for admittance and being able to add admittance. It's something we're looking into, but that's as far as I can go on. Running DMAG changes CT ratio, how much of a change? It varies depending on how magnetized that CT is, if it at all, or two, what that CT or how that CT affects when burden is applied. Those usually are the two factors for that, is how it handles the burden change as well as how magnetized, if at all, that CT is. For example, these CTs behind me are 1 under 5 CTs that we've been using around here for a while. They've never been exposed to any kind of lightning strikes or anything like their office CTs that we use. And I just ran a DMAG on it today. The ratio didn't change. Nothing changed with that ratio because these have never been out in the field. They've never been in true three-phase service. So it depends on the situation. It depends on the site. It depends on what that CT has been through to affect its ratio. Next one, some test results were out over the 0.3 accuracy class. I was selected and showing green. Where can this value be set to pass and fail? Green and red. So, unlike meter testing on the RW Bantam Plus, CT tests will always show green. There is no pass or fail on a CT test in our software to determine flag red or flag green for pass and fail for CT. Reason for that being, we let the utility make a call on what passes and what fails as a CT versus our equipment being black and white and saying you have a failed CT. CT test results can then be used to bring up to your utility or yourself or whoever you're working with to determine, hey, is this CT something we need to address, or is this something that is acceptable for this service? So, unfortunately, there's no green or red check mark for these. For the test done with the measurement circuit measuring normally with user load operating under normal conditions. Typically, yes. Now, if you've been out in the field, you probably know that the current flow that you'll get on the secondary isn't always going to be steady. The RW handles that pretty well in terms of fluctuating current loads. So if for some reason they turn on the AC or the heater right when you're out on the site and testing, it can handle that. Bantam Plus will handle that as well with some stipulation, but the RW will definitely handle that kind of load. So my example load behind here is perfect, typical operating conditions for demonstration. Can you show the results in graph performance? Absolutely. Let me bring that up over here. So this is the parallelogram graph that I got based on my A, B, and C phase CT test results. Granted, this is for the class 1.2 because I only typed in the 0.3 on A phase, and the rest being blank. So it's erroring out on me. So if I change that back to you can see based on 0.3 that even this is a little bit outside of that typical parallelogram. Next question, do all RWs have the built-in dead site test option, or is that something that has to be added in as an option? It is an accessory for the RW, so you will need a CT current boost accessory to perform dead site tests, to give that 200 amp boost that I keep talking about. It is a standalone accessory, comes in a little box that you can then use to power primaries of CTs to either bench test or boost a low load or no load application out there. Please provide presentation documentation. For that one, go ahead and email us and let us know what you're looking for, and maybe I can get the documentation. Let's see. Does the Bantam log as found and as left test result after DMAG? It does not. So if you're looking to see a before and after, what I would recommend is run a test on each phase, and this goes for the RW as well. Run a test on each phase, save those results, demagnetize the CT, and then rerun your test results, and then you can do a compare and contrast between the results you did first and then the results you did second. In that regard. Clamp-on CT has a greater phase shift. So how to compare solid core CT? If you're having issues with a specific probe or a specific type of CTs, typically if you're having issues with one specific probe or a specific CT over the other, that's if it's the CT side, you might need to look at what CTs you're using, and if it's something on the CT side that's causing issues with phase shifting between each one, or if it's the probe itself. Some probes are accurate to 1% plus or minus, while others get way more accurate than that. Usually the clamp probes are slightly more accurate than the rope probes, CenterLink being a bit more accurate than both of those. So depending on what you're saying, you might need to look at the probe or the CT. Hopefully that answers that question. Another question I saw is, can you move the CT probe without waiting after you hear the beep on the RW? Preferably not. You can, but you won't get good results. And the reason being is that beep occurs when the test is done. If you move it before, you're killing the primary reading during the reading process of the RW. If you do that, then you're going to probably ruin part of the end of the burden test, so you'll see some real high error on the when it does beep, that's when you can go ahead and move it. You know that the RW's done its measurements, you're good, you can move it over that way. You mentioned the DMAG should be used when your ratio is high. What is considered high? That's I would say that's kind of up to you or the utility or somebody, whoever's doing the CT test to determine what's high. Usually the CT has a accuracy class to it, and by using the RW without the DMAG portion, if you're getting that high ratio of some sort, and it seems to be fairly off compared to the nameplate and its base accuracy in the conditions that it's in, whether it's within optimal load, so if it's under that load threshold that I'm thinking of, or if it's within its loaded specifications accurate at this percentage under this amount of load at this temperature, putting all of those factors into play that the RW really doesn't take into consideration during the CT test, that's when you can kind of help consider, hey, is this something I consider to be a high result or not, and try to run the DMAG. There's multiple factors that go into considering that. Any other questions I can answer for you guys? All of these have been fantastic. I appreciate all the questions. How long does DMAG take? About 5 seconds. It is a very quick process. I click the DMAG button and it goes and does its thing in about 5 seconds. Ramp up burden, ramp down burden, it's done. It's a very quick process. Any other questions? I'll give about 15 more seconds for any other questions. Oh, there we go. Do you offer adapter cables available for probes that we're already using? The answer is yes. Typically, if there's a BNC output or a fiber optic output for like CenterLinks, something like that, we offer different adapters to allow the connections for the Riddell connector on both the TSB-R1 and the RW to hook up with probes that you might already have. Going into that, we can also calibrate most current probes to your piece of equipment. So if you have an RW and you're using a specific probe with that, we can calibrate that here at Radian to a little adapter. We call it an RC-CTA1 adapter, current test adapter. And we can put constants in there and other things using our calibration lab downstairs and run a calibration on your probe and help it become accurate with the RW band plus using an adapter. So yes, we do have adapters for most probes out there that you might already be using. A couple questions flooded in, so let me scroll up here real quick. Are there downsides to demagging? I'm assuming we're CTs out of it. The only real downside to demagnetization that I personally am aware of is, again, a possibility of changing the ratio of your CT, usually lower. That's the only downside that I know of. So would it make sense to start a test procedure with demag? Not particularly. Typically, what I would recommend is what I would suggest earlier on, which was get a as found per se result, see what it is first before you start running the demag one. So if you have A, B, and C phase CTs, depending on what those read as found, that's when you can then decide, okay, do I want to run the demag or do I want to skip that, and do I think this site's okay as is? So I wouldn't start with it, but I would run it based off of what you see on an as found test and what you see when you first get on the site. Does the demag function work with low ampacity or no ampacity? Yes, it does. It does not need current to perform the demag function on the RW. Well, the high voltage probes for the BirdDog Plus work with the RW. It depends on what high voltage probe you're using. To be honest, I probably have to see it. So if you have a question on if that probe will work for the RW, I recommend sending us an email, maybe putting a picture of that probe in your email as well, and then we can take a look at that probe and let you know specifically if that make and model of probe that you're using will work with your RW. Don't CTs demagnet themselves over time anyway due to the burden of your secondary wire. That is true. If burdens change or fluctuate in that circuit naturally over time, it should demagnetize itself. But let's say you're going to test out a week after a large storm, something might have happened. Demagnetization is a very touchy isn't the right word, but very open topic. As you can see by all the questions, it varies. It's not a bad thing to do, but it's also not always necessary. It always depends on what you're reading at the CT, and if you feel that demagnetization will help the accuracy of that CT that you're testing. Again, going right back to what I said earlier, I appreciate all your guys' questions. If you have any more, please throw them in chat. I'll be happy to answer them. I'll give about 15, 30 more seconds for any additional questions. I appreciate the thanks, Bob. Thank you. All right, moving on to the final part. A little bit of promotional material. As we do often, we have our We Meet 2020. I'll be coming up later on this year in September. It will be held September 15th, 16th, and 17th. This is a user event where customers and other people out in the electrical industry come sign up for a We Meet event, see our latest hardware and software advances, as well as hands-on training by myself and others here at Radian, get hands-on with some equipment, directly engage with us, fellow utility members, fellow metermen, fellow industry leaders and experts, as well as support, sales, and other people from Radian as well, and get 3 days of hands-on, what you want to see and what we've scheduled as well, and get some real practical experience with some of our equipment right alongside us here at Radian. If you're interested in that, you can register today, radianresearch.com. We have a link there that will help you register for our We Meets event coming up in September. with that, I want to thank you all for attending my CT testing webinar. If you have any other questions or anything that we can answer for you, we have our website, radianresearch.com. As well, you can also email us all, myself included, at technicalsupport@radianresearch.com, or feel free to give us a call at 765-449-5576. We here at Radian enjoy being your solutions partner and look forward to working with you throughout any of your testing applications. If you have any questions, please feel free to give us a call or shoot us an email, and we'll be happy to see you in the next presentation or our next webinar. Thank you, and I hope you guys have a great day.